All right, everyone, welcome back. This is lesson 2 now of our trigonometry unit. Again, these are going to be kind of long, so take your time, maybe do one page, start some of the homework, and then come back to it maybe another time or another day, and do the second page if you need to, okay? We are going to continue on with our SOHCAHTOA, okay? You've done this before, so this isn't going to be new for you today. We're also going to look into word problems, okay? So we are going to start with finding the lengths of sides using SOHCAHTOA, okay? So what we're going to do here is we're going to use SOHCAHTOA. So we're going to find a sine, cos, or tangent, okay? Excuse me. And then we're going to create an equation to solve, okay? And so there will be a variable like x or something, and you're going to use sine, cos, and tan to create an equation. We're going to solve for x. You will need a calculator. You need a scientific calculator. So your like TI 36 or your Casio, or a couple of you have graphing calculators, you'll need that. So if you don't have it with you right now, I would pause and go grab it, okay? If you don't have a calculator, I'm going to show you how to do it on the scientific calculator on Google. That's all I'm going to do. I'm going to show you how to use that, okay? And one of the big things that we get to our calculator is I'm going to stress is that you need to make sure, okay, the calculator is in what we call degree mode. Okay, degree mode. Because there's also radian mode, which we will learn about next section, okay? But for right now, we need it in degree mode. And I'll show you how to differentiate between the degree and the radian and to go back and forth, okay? All right, so we're going to start with number 1 here. We're going to find the value of x, round it to the nearest tenth, okay? So always follow the directions. I think the directions for most of these sections are to the nearest tenth, okay? And so we're going to look at this triangle, and we're going to use our sine, cosine, and tangent functions, okay? And so sine, cosine, and tangent are always of an angle. So always take the angle that is there. So in this case, 64 degrees. Never use the 90-degree angle. Okay, don't ever use the 90. But we see the 64 degrees, and look at the information they give you. From that 64 degrees, this x is opposite the 64. And the 25 is the hypotenuse for this 64-degree angle in this right triangle, okay? And so then you'll go back to SOHCAHTOA and you'll think, okay, which one's opposite and hypotenuse? And hopefully you see that it's sine. And so you'll go, okay, I know then that we have the sine of the angle 64 degrees, okay? Sine, cosine, and tangent are always of an angle. Okay, it's always of an angle. And it's going to be equal to the opposite over the hypotenuse. In this case, x over 25. Okay, so it's always sine of an angle equals a fraction. Okay, or cosine or tangent of an angle equals a fraction. And so what you've done is you used your SOHCAHTOA and you've created an equation, and you need to solve for x. And so now we're going to get to solving for x. So I see that x right now is being divided by 25. So to solve for x, I'm going to multiply by 25 on both sides. Okay, so these 25s will go away, and what I have is 25 times sine of 64 degrees. That's going to be our x value. Now be careful, a lot of people want to multiply 25 times 64, and that is not the case. That is not how it works, okay? We're going to be multiplying 25 times the sine of 64 degrees. Sine of 64 degrees has a specific number attached to it. So we're going to multiply 25 to the sine of 64 degrees. Thankfully, our calculator knows what the number of sine 64 degrees is, so that's what we're going to look at. So let's take a first look at our calculator. Okay, if you are using you don't have a calculator at home and you're just going to use your Google calculator, okay? All you have to do is Google scientific calculator. Oh, mine's already there, so just Google scientific calculator. and 1 pops up right for you. So it's perfect, okay? And we'll start from there, okay? So we need 25 times sine of 64 degrees. Now, this is what I'm talking about. We need to be in degree mode. So you'll notice, I can't write on this, but you'll notice at the top left of this calculator, it says rad, that means radian, and then DEG means degree. So I'm gonna click on degree so that we are in degree mode here. Oops, gonna highlight degree, DEG, okay? And now I am in degree mode. I have to be in degree mode or else our answers will be incorrect. So it's important that you practice this. If you were on a TI calculator or Casio calculator, you want to look in the screen to see if it says DEG or maybe just capital D. If it says R or RAD, that's in radian. So you want to be in DEG. And you're going to change it by changing the mode. It could be in various places, but I believe on the TI calculator, it's under DRG, and you want to change it to degree. Okay, so that's what you want to check to make sure. And my quick check to make sure I'm in degree mode is I always hit sine of 30 degrees. Okay, sine of 30 degrees is always 0.5. And so now I know that I have it in degree mode. And I'll show you, like if I had it in radian mode, sine of 30 degrees is going to be some random number. And that is not my random number. I need it in degree mode. And we have sine of 30 degrees equals 0.5, and so I know I'm in degree mode. It's correct. So that's always my buffer to check to make sure I have it clicked on the right one. So if you check your calculator, sine of 30 degrees equal to 0.5, okay? If that's your answer, then you're correct. You're in degree mode, okay? Going back to the problem, we are multiplying 25 times sine 64 degrees. So I'm going to have 25, and I'm going to multiply, and I'm going to multiply it times sine of 64 degrees. I'll close my parentheses, and I'll hit enter, and I see that it's 22.46985, ... I'm rounding to their nearest tenth, so it's 22.5. So I'm going to go back to my answer, and I'm going to say, okay, 25 times sine 64 is going to be 22.5, and that's equal to our x value. And we are done with the problem. Okay, so again, you want to make sure you are plugging these in correctly with the numbers, so you want to practice on your calculator. This might be something new for you. Make sure you're in degree mode and you get the numbers correctly. I'm not going to do number 2, but you can try it on your own, and here's the answer. You can check that, pause it yourself, and you can check on your own. I'm going to go to number 3 now. Okay, same idea. We start with the angle that's given to us. That's this angle. It's 18 degrees, and I look at the information they gave us. They gave us this side x, which is adjacent to the 18 degrees, and this side 34, which is the hypotenuse. And using SOHCAHTOA, that's going to be our cosine function. And so I'm going to say cosine, of 18 degrees is equal to x, the adjacent, divided by the hypotenuse 34. Okay, so cosine 18 degrees, again, has a specific number attached to it, a specific ratio. The ratio is going to be whatever x over 34 is. I don't know what x is, but there's a specific number x that gives me cosine of 18 degrees, always. Okay, I'm fixing that x. And so we're going to find out what that x is by doing a little multiplication here. I can multiply by 34 on both sides, solving for x. And so 34 times the cosine of 18 degrees, that's going to be my x value. And so again, I'll go to my calculator. I won't do this every time, but I'll do it for right now. So I'm going to do 34 times the cosine now of 18 degrees, close my parentheses, I am in degree mode, and I get 32.3 rounded to the 10th place, 32.3. Okay, so 32.3, that is going to be my value of x. And so the length of that side is 32.3. Okay. All right, let's keep going now. We're going to do another problem, same idea, same setup, just the solving is going to be just a little bit different, okay? But same idea, I have this 35-degree angle. From this angle, I have this side is opposite, the 9 is opposite, and the x is adjacent. So opposite and adjacent using SOHCAHTOA is going to be our tangent. So I have tangent of 35 degrees equals the opposite 9 over the adjacent x. And we've set up our equation, okay? Now, the difference here is x is in the denominator. So you could do a couple things. You can divide by 9 and then kind of flip it over, or you can multiply by x and then divide by tan 35. But I'm just going to say the shortcut for you, or you can cross multiply too, okay? The shortcut on these problems is when x is in the denominator is you need to take this tan 35 and just flip it with the x. And so what I get, instead of tan 35, I have x, and that'll equal 9 divided by the tan 35 degrees, okay? So you just flip those two, and that's going to be the quickest and shortest way to solving this. Instead of going through all of the steps, we're just going to do that one step, okay? And then again, this is something you plug in your calculator. You take 9 and you divide it by tan 35. So I'm going to come over to my calculator. Let's clear all this. Oops. And I hit 9 and I hit divided by tangent of 35. Close my parenthesis, and rounding to 1 decimal, I see it's 12.9, 12.9. So I'm going to come back here, and I see that my x value is 12.9. And we are done, okay? So again, same idea, just when x is in the denominator, you have to solve it in a different way, order of operations, okay? One last one and we'll move on. I have this 30-degree angle here, and with this 30-degree angle, I have the 18, is adjacent to it, and the x is the hypotenuse. Remember, the hypotenuse is always across from the right angle. It's the longest side of the right triangle. So adjacent hypotenuse is going to be cosine, so I have cosine of 30 degrees will equal adjacent 18 divided by hypotenuse x. And this is the same situation we had before. All I'm going to do is take this cos 30 and I'm going to switch it with the x so that x is equal to 18 divided by cosine of 30 degrees. Again, this is just a shortcut. Instead of doing the division of the 18 and multiplying by x and things like that, I'm just going straight into this. And so then we get our calculator, 18 divided by cosine of 30. You should be following along and pausing it and plugging it in your calculator because you need the practice with the calculator, okay? So 18 divided by cos 30, if you do that on your calculator, you will get 20.8, okay? So make sure you're getting these correct answers, okay? And that's it for the first part, okay? That is finding side lengths in right triangles given an angle and a couple of sides, okay? Again, you're using SOHCAHTOA, and you need to make sure your calculator's in degree mode, okay? Now we're going to go on and say, all right, what if I know two sides and I want to know the angle, okay? When you are looking for an angle, okay, you are going to use what we call the inverse of sine, cos, and tan, the inverse, okay? So when finding an angle, just going to make a little note here, when finding an angle, and we use the angle theta, okay, but it could be any variable. It could be x, it could be angle A, it could be angle L, it doesn't matter, okay? But sometimes a lot of times we use theta, okay? What we do is we use something called the inverse. And the inverse is represented with that little -1 power, okay? We've talked about inverse functions, and we saw that -1, same idea. This isn't to the -1 power, but that's where it is. It kind of looks like the exponent, okay? It's a superscript. That's what we're using. You might also see on your calculator something called arc sine. That is the same exact thing. It's inverse sine is what it is, okay? So we'll be using this, and I'll show you how. So sine of theta equals x. Then, okay, if I wanted to know what theta is, what I'm going to do is I'm going to take the inverse sine, and I'm going to take the inverse of whatever my ratio x is, okay? X is some sort of ratio. It's the opposite over hypotenuse. Whatever that ratio is, I'm going to take the inverse of it and work my way backwards to find the angle. So what I have above here, when I have something like sine 64 equals x over 25, the angle of 64 degrees, the sine there has a specific ratio. The ratio is 22.5 over 25, okay? That is the ratio every single time for sine of 64 degrees, okay? So what I'm going to try to do is, let's say I'm going to be given 22.5 over 25. I'm going to find the angle associated with that ratio for sine, and it's going to be 64 degrees. And we're going to do that in our calculator. Our calculator has all this information, okay? So that's for sine. We'll do the same thing for cosine. If I'm looking for theta, the angle theta, I'll do the inverse of cosine of whatever the ratio for cosine is. Okay, and then I will do the same thing for tangent. If I'm looking for theta, I'll do the inverse tangent of whatever that ratio is. Okay, so whenever you're looking or solving for an angle, you will use the inverse. So let's try a couple of these problems. Okay, the fun thing is, I mean, not fun to you, is we set up the equations the same exact way using SOHCAHTOA. Okay, so I see my angle theta here, just like we did before, but just now I don't know what the angle measurement is, okay? But I do know the angle opposite, or side opposite theta is this 8, so this is my opposite, and the 14 is my adjacent to the angle, okay? And so opposite and adjacent, that's going to be tangent. So then I have tangent of theta is going to be equal to the opposite 8 over the adjacent 14. Okay, so I've set up an equation, all right? But I need to solve for theta. Now, let me just make something very clear. Do not write this down right now. This isn't tangent times theta, okay? I'm not going to divide by a tangent. That's not how this works, okay? Tangent theta, this whole thing, is its own value. Okay, it has a value. That value is the ratio 8 over 14. Now, I just need to figure out what the angle is for this specific value that's going to give me the ratio 8 over 14. So that's what I'm doing, okay? And again, now we're solving for the angle. So whenever we solve for the angle, okay, we are going to use the inverse. So I'm going to use the inverse tangent, and now I'm going to plug in 8 over 14, okay? And so now I have to use my calculator. So I'm going to go back to the calculator. Inverse tan of 8 over 14 is what I want. Let me clear it. Okay. So for some of you, if you're on like a real calculator, you're going to have to hit shift or second and then tan, and the tan to the -1 will show up. Okay, so you have to hit shift or second. If you're on this Google calculator, I'm going to click the inverse button, the INV. It's right below the rad, INV. And now you see it pops up as sine -1, cosine -1, and tan -1. Okay, and so that's what we're going to enter now. I'm going to hit tan -1. Notice it pops up as arctan. It's the same thing. Tan -1 and arctan are the exact same thing. If you're using a real calculator, it'll say tan to the -1. And then you want to put 8/14 in, okay? So you put 8 divided by 14. Make sure you close your fraction. Close that inverse tangent because you're doing 8/14, not inverse tan of 8 and then divided by 14, and you hit enter, and I get 29.7. That is my angle measurement for theta. Again, be careful, make sure you are in degree mode, okay? So 29.7, I'm going to come back here. Did I say 29.7? Sorry, going back. Yeah, 29.7, good. Okay, 29.7, that is going to be my angle. So when I do the inverse tan of 8 over 14, I get 29.7, and this is degrees because we are in degree mode, okay? All right, one more, and then we'll move on. Same idea. This is the angle I'm looking for. I have this piece here is adjacent, and my 40 is going to be the hypotenuse. hypotenuse always opposite the right angle. Okay, adjacent and hypotenuse is going to be cosine. So I have cosine of angle theta. Sine, cosine, tan are always of an angle, whether it's a number or a variable like theta. It's always of an angle, okay? And then it equals the sides. In this case, adjacent over hypotenuse, 38 over 40. It's not working. Okay. And so to solve for the angle, we make this an inverse cosine of 38 over 40. And we're going to go to the calculator, and what your calculator is going to do is it's going to take the ratio and it's going to tell you what the angle associated with that ratio is. Sorry, my stylus isn't working. Let me erase that. 40. Okay, so let's go back and do inverse cosine of 38 over 40. Oops, not that. This. All right, clear all that. So again, I'm going to hit inverse cosine. If you're on the calculator, it's second or shift cosine. And you'll get cosine to the -1, or arc cos as we see here. And we're going to do 38 divided by 40. Close our parenthesis, hit equals, and I see that it's 18.2 degrees, rounded to the nearest tenth, 18.2 degrees. So I have 18.2 degrees. And that's going to be our angle theta that has a ratio of 38 over 40. Okay, the ratio 38 over 40 for every cosine will always have an angle of 18.2 degrees because that's how they are related. Okay. All right, if you would like to try 9 and 10 on your own, go ahead and pause, and then you can come back and check your answer. Again, this is important to do so you know that you've practiced on the calculator and you know how to do this. Okay. All right, next part, we're going to move on to angles of elevation and depression. You did this in geometry as well. It's the same thing. We're going to set up an equation, but the hard part is we have to draw the picture from the description in the word problem, okay? Let's really quick talk about elevation and depression, okay? An angle of elevation will always come from a horizontal line, always, okay? And it like goes up here, and this is your angle of elevation, okay? So it always goes up. That's your angle of elevation. Where an angle of depression, okay, again, comes from a horizontal line, but then it goes down. That's your angle of depression, okay? So angles of elevation and depression never come from a vertical. They always come from the horizontal line. So if they tell you the angle of elevation is this or the depression is this, you need to draw horizontal, and then you either go up if it's elevation and down if it's depression, okay? Always from a horizontal. So on number 11, we have the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. So there we go. I have an angle of elevation. Okay. So I'm going to come from a horizontal line, and I'm going to go up, and I'm going to create an angle. Let's make it better. Hold on, let me make it look better. Okay. I'm going to go up, and then I'm going to create an angle of elevation that is 5 degrees. Okay. So my boat is here. Okay, and the top of the lighthouse is up here, and then we can finish our triangle. So this is the top of the lighthouse. Okay. It also says if the top of the lighthouse is 161 feet above sea level, okay, how far is the boat from the lighthouse? So we want to know, when we want to know how far, usually it's like a horizontal or vertical distance, okay? So this is X. We are not looking for the length of the diagonal, okay? That'll be in different situations, okay? So we want to know from the boat to the lighthouse. And so we're going to be looking for that X there. Don't worry about this little extra piece here. That's not part of the triangle, okay? And once you have that, once you have your triangle, you can set up your SOHCAHTOA in order to find the value of x. So from my 5-degree angle, I have 161 as the opposite and x is the adjacent. Opposite and adjacent make tangent. So I have the tangent of 5 degrees equals 161 over x. And now I'm going to solve for x, okay? We did this right above. These are the same types of problems that we started out with, okay? If I want to solve for x in this case, I'm going to switch the tangent of 5 degrees with the x. So x is equal to 161 divided by tangent of 5 degrees. Okay, you'll go to your calculator, you will make sure you're in degree mode, you type in 161 divided by tangent 5 degrees, close your parenthesis, and you will see that you get 1,840.2 feet. The boat is 1,840.2 feet from the lighthouse. Okay. So again, same as the types of problems above, but you have to create the picture and then create the equation. Okay, go ahead and try number 12 if you like and pause. Make sure your calculator's in degree mode and then you can check your work to see if you did it correctly. Uh-oh, I put the wrong answer on this one. Hold on. I didn't do it correctly. Oops. I just realized I had the same answer written down. The answer for number 12 is 23 feet. 23.0 feet. Okay. So if you check your work, now it's correct. All right, moving on to number 13, and then we'll do a couple depressions and we'll be done. So a 10-foot ramp is used to unload furniture from a truck. So think of a ramp, okay? Here's our ramp, and it says this ramp is 10 feet, okay? If the back of the truck sits 3 feet above the ground, so here's the truck, and it's sitting 3 feet above the ground, okay, find the measure of the angle the ramp makes with the ground. So here's the ground, okay, and we want to look for this angle x, theta, you can call it whatever you want, okay? And so from this angle, x here, I have 3 is opposite, and 10 is the hypotenuse in my right triangle. They always make a right triangle, by the way. And so opposite and hypotenuse, is going to be the sine function. So I have sine of whatever angle in degrees is going to equal 3 over 10. In order to solve for an angle, we use, again, the inverse. Whenever you're solving for an angle, you will find the inverse. So inverse sine of 3/10, that is something I go to my calculator, I hit inverse sine, I type in 3 divided by 10, I close my parenthesis, and you will see that it's 17.5 degrees. Okay. And that's angles of elevation, okay? So what we just found was the angle of elevation from the ground to the ramp, okay? All right, last couple. Now we're going to look at depression. So it says a fire is spotted from the top of a 125-foot tall tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? Okay, so you have a tower. I'm gonna pick a different color now. Okay, and this tower is 125 feet tall. Okay, and it says the angle of depression to the fire, so let's say the fire is down here somewhere, okay, that angle of depression is going to be 19 degrees. Now, a lot of people always make a mistake and put the 19 degrees here, okay? That is not correct. Depression angles come from a horizontal. So my depression angle is coming from this imaginary horizontal line here. Okay, and my angle of depression goes down, and so this angle is 19 degrees. Okay, then the question is how far is the fire from the base of the tower? So we're looking for this x here, from the fire to the base of that tower. Okay, there's a couple different ways you can look at this. All right, if you have that angle of depression, remember alternate interior angles, okay? This angle right here is going to be the same exact angle. It's also going to be 19 degrees, okay? So these angles are the same. Or you could look at it as a rectangle, Okay, a rectangle, the opposite sides are equal, so I can call this piece up here x, and this piece to the right 125 as well. And then you can create, and you can look at that green triangle instead of the purple triangle. So it doesn't matter which one you use, the green triangle or the purple triangle, it's up to you. But make sure you put the angle in the correct place, okay? So now as I start, I'm going to see 19 degrees. And I say this is the opposite and this is the adjacent, so I will be using tangent. If you use the purple triangle, okay, then from this 19 degrees, again 125 is the opposite and x is the adjacent, and so I use tan. It's the same exact thing, okay? So you pick which one, make sure you put the 19 degrees in the correct spot. That's the important part. So no matter what, we have tangent of 19 degrees. Tangent 19 degrees. That is going to equal the opposite, 125, over the adjacent x. And now we just need to solve for x, okay? On these ones, we switch the x with the tan 19. X is equal to 125 divided by tangent 19 degrees, okay? And this is something you go to your calculator for. You plug in 125 divided by tangent 19 degrees and make sure you're in degree mode. And you get 363.0 feet. Remember, we're rounding to the 10th place. Okay? And so that's an angle of depression. You're going to kind of create, again, that rectangle or use alternate interiors. Okay? One more problem. You can try number 15 on your own, but one more problem and we will be done. Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet and the ball travels 76 feet, what is the angle of depression from Max to the player? Okay, so we'll start. Max is somewhere up here in the stands, and then there's going to be a baseball player at first base right here. Okay. It says the horizontal distance from Max to the player is 61 feet. So let's draw a triangle here. Oops. That's not a very good triangle, is it? 61 feet, because that's the horizontal distance. And the ball travels 76 feet. So from Max to first base, that is where the ball travels. That's 76 feet. Okay, and we want to know what the angle of depression is. Angle of depression, again, comes from a horizontal, so this is going to be my angle of depression. I'll call that theta. You can make the rectangle and say, okay, the hypotenuse is 76, the length over here is going to be 61, or you can say alternate interior angles and say that is angle theta. Whether you want to use the red triangle or the purple triangle is up to you. No matter what, we have this is the adjacent, the 61 is adjacent, and the 76 is the hypotenuse. Adjacent and hypotenuse is going to be cosine. So we have cosine of angle theta, or whatever you want to call the angle, you can call it x, okay, is equal to adjacent 61 over hypotenuse 76, and we need to figure out the angle that's associated with cosine for this specific ratio, 61 over 76. So we say, okay, theta is equal to the inverse cosine of 61 over 76. You put that in your calculator, inverse cosine. 61 divided by 76, close your parenthesis, and you get 36.6 degrees. Okay? And that is the angle of depression. And we are done. Again, I'm sorry, I apologize, these are long lessons, but they're super important, so hopefully you stuck with it till the end. If you have any questions, always email me, or we can Zoom and try the homework that is associated with this, okay? Take care, have a great week, and we'll see you in the next lesson.